Okay, we're continuing on in Unit 2. Let me just move this a little bit. There we go. We're going to talk about formulas and names of ionic compounds. And remember that ionic compounds are formed between a metal and a nonmetal, or it can be a polyatomic ion. Now, polyatomic ion, these are like phosphate, PO4, 3-, ammonium. We'll talk about them a little bit later. The main thing I don't want you to stress about is polyatomic ions are not required for memorization in this course. Maybe for other chemistry courses they have been required, but for this course, they will be provided to you. Okay. So when it comes to naming ionic compounds, it can be helpful to learn how to name ions first and then learn how to name the compounds. Now remember, ionic compounds are neutral. The charges add up to 0. Whereas ions are charged. Okay. So I think there is a car called the ion, but anytime you have an ion, it's either a positive or a negative charge. Cations have a positive charge. So a cation, I always think of it, the T, positive charge. So your metal group ions are going to have positive charges on them. So metal group ions 1, 2, and 3 are named by listing the metal followed by the word ion. So like potassium, when it's an ion, it's K plus 1. It would be called potassium ion. Now if I have this on a test, K plus 1, and you just put potassium, that is incorrect. Potassium implies a neutral species, like just the metal, K. When you have potassium with a charge, that is an ion. So that's why you have to say potassium ion. All right. Magnesium. And by the way, with these charges, it can either have you can have the plus written first or the plus written after. This would just be named magnesium ion, and aluminum has a +3 charge. That would be aluminum ion. Now, transition metals. Remember, transition metals are, get my book right here for you. Transition metals are this area here. The unique thing about transition metals is they have charges that vary. Whereas, group 1 is +1, group 2 +2, group 3 +3. Transition metals, it depends. Iron, for instance, right here, can have a +2 or a +3. Nickel could be +2 or +3. Now I know these. I don't expect you to know these. But transition metals, it really depends. So because different transition metals can have different charges, we need to specify that. For this class, we're just going to learn how to name transition metals one way. So the way that you name transition metals is just the metal name with a Roman numeral indicating the charge, and then ion. So this, chromium, is a transition metal, and I can verify that by going to the periodic table. Chromium is atomic number 24, so it is in the transition metals. This is chromium 2 ion, while this is chromium 3 ion. So if you just said chromium ion, it's ambiguous. That's why we need to put the Roman numerals. So that's how we name cations. Anions, these are negatively charged ions, so negative ions. Anions are named by replacing the ending of an element with IDE followed by the word ion. So this is like where you get chloride or bromide or sulfide. And sometimes you're like, well, how does she get this? I do not get this nomenclature. So these are all nonmetals that gain electrons when they're involved in ionic bonding. So they're going to get a negative charge. They will be an anion. So bromide, this is bromine, but when it becomes an ion, it's bromide ion. Oxide, oxygen's in group 6, it's going to gain 2 electrons, so it's going to be negative 2. This would be oxide ion. Sulfur's in group 6, it's going to be negative 2 as well, and then it will be sulfide ion. Nitrogen is in group 5, it gains 3 electrons to get an octet, so it has a negative 3 charge. It will be nitride ion. And then phosphorus is also in group 5. It gains 3 electrons, so it has a negative 3 charge. Phosphide ion. So we've learned how to name cations. We've learned how to name anions. The key with all of these is that they have the word ion after the name. Now remember, ionic compounds are for neutral species. So ionic compounds don't have a charge. They don't have ions. So the way you name ionic compounds, you list the cation name first. Don't forget Roman numerals if it's a transition metal, followed by the anion name. Big thing about this, the word ion never appears in the name of ionic compounds. So this compound here, BAS, this is barium, and then sulfur, change the ending to IDE, barium sulfide. So notice that there is no ion that appears in this name. Okay, the next one, aluminum and fluoride. So this is just aluminum fluoride. Aluminum is not a transition metal, so I don't have to put a Roman numeral. Same thing with barium. Barium is in group 2, and aluminum is in group 3. It's not a transition metal. You know, I'm looking at your periodic table, and the way your, the way your periodic table has transition metals and right here. So it's a metal, but not a transition metal. So that's why it's just aluminum fluoride. And lastly, we have K2S. So K is potassium. This is in group 1. S is sulfur, but you change the ending to IDE, so it's potassium sulfide. So nomenclature at first is very intimidating. You don't know what you're doing. You get them wrong. We have a lot of practice problems online. I strongly encourage you to do those, and the explanations are given in great detail. Practice, practice, practice. Practice your homework problems as well. I don't think you can ever get too much practice with this nomenclature. Even after you have named them, you've gone through and done all the practice problems, you will surprise yourself by going back and naming them again and you might miss a little detail. So much of chemistry is detail-oriented. You might have left off a Roman numeral, or maybe you left off the word ion. It's really nitpicky, and I always tell my students that, chemistry requires you to be very anal and detail-oriented. And, sometimes it drives my husband crazy because I'm so detail-oriented. Do you see that little thing right there? You see, it's like, oh, yes, that's right. You teach chemistry. Anyways, but there is a reason that you have to pay attention to these little things, because if you don't tell, if you don't give the charge in a transition metal, then it's ambiguous as to what compound you're talking about. And with chemistry, it's really important to be able to communicate quickly what you're talking about, so in journals, it's clear. If you ever have an emergency with chemicals, they need to know what form of iron they're dealing with, or whatever it may be. So, more practice. Never hurts to have more practice. All right, this CAS, calcium is in group 2, and so it's not a transition metal. So this is just going to be calcium sulfide. No Roman numerals. All right, these next two, once you hit pause and try to name them, and then when you come back, I'll explain how to name these, but just kind of practice doing them on your own, because on the exam, I won't be working through these with you. Okay, so this is aluminum, sulfide. And this is zinc chloride. Now, if you're ever wondering, I can give an example of a transition metal. Let me give you one now. Let's say I had Fe2O3. This is iron oxide. Iron is a transition metal. It is right here. It's a transition metal. That means I have to put a charge. What charge would I put? If you're unsure of the charge, some periodic tables have them written. Periodic table I gave you has it written in a little square. Let me get mine. Okay, so I'm looking at iron, and you see it has those little teeny tiny numbers written above it, 3, 2, and 6. Those are the potential charges it could have. You can look at this periodic table to verify that the charge you get on the transition metal is indeed correct, or you can also do the cross and raise. So cross it and raise it, so that makes this iron 3 oxide. So that's how you would name a transition metal. The other skill that you need to have with ionic compounds is writing formulas from names. Each student I talk to with this has their way that they prefer. Either they like to write formulas from names, or they like to write names from formulas. Everybody's a little different. And this is where it's helpful to have a study group, because sometimes you might be better at writing formulas from names, and maybe your study buddy is good at writing the names from the formula. So it just depends, and if it's one of your weaknesses, you can teach each other. Or if you know that you're particularly weak in a certain area and you don't have time to meet up with other students, you can always practice this several times. Oh, this is my weak point. I need to do more practice problems. Okay, so when you're given a name and you need to write a formula, the easiest thing to do is to write out the charge. So calcium is in group 2, so it's going to have a +2 charge. chloride is in group 7. It's going to have a -1 charge. So I've written the abbreviations and the charges. Now I'm just going to do cross and drop, and you should get CaCl2. One of my former coworkers, and she doesn't teach here anymore. She's moved, but she used to do the John Travolta dance moves, you know, when she would do the cross and drop. So I always have that image in my head when I do the cross and drop with these formulas. But this cross and drop method is very handy for making ionic compounds neutral. The only time you have to be careful is if you can simplify them. And I'll show you an example coming up. But this can't be simplified because you have a coefficient of 1 and a coefficient, not a coefficient, a subscript of 1 and a subscript of 2. So you can't simplify that any further. You have to have whole number subscripts. The next thing about this cross and drop is it makes a neutral compound, like I mentioned just a second ago. So you can always check yourself. This is +2, and this is 2 times -1 equals 0. All right, now aluminum oxide. Again, write your charges. Aluminum's in group 3. It's going to have a +3 charge. Oxygen's in group 6. It's going to have a -2 charge. You do the cross and drop, and you get Al2O3. And these can't be simplified. They're written in the simplest form. Okay, lastly, zinc oxide. Now, you might be saying, hey, zinc is a transition metal. Why isn't she saying zinc 2 oxide? It is true that zinc is a transition metal, and I applaud you for being aware of that. You were probably wondering, this zinc chloride example up here, why didn't I say zinc 2 chloride? Zinc is a transition metal that only has 1 charge. So if you ever come across a transition metal that just has 1 charge, you don't have to put a Roman numeral. And I know you're probably thinking, oh my gosh, these rules in chemistry are driving me crazy. How can I keep track of all this? You will get it. It just takes practice. Practice, 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 practice. I was amazed when I was studying chemistry. I would do my homework problems, and then we'd have a test or a quiz, and I'd redo my homework problems. And it was as if I had not done these homework problems. So this is coming from somebody who teaches chemistry. It is not easy, and you need to keep doing it over and over again. But what I found is that if I did my homework problems multiple times and used different sheets of paper, didn't look at my old work, then by the time I took that quiz or that exam, I was very well prepared. But it takes practice. That's why I love chemistry, because it was a challenging subject for me. So, you know, I think a lot of people think, oh, it must have been really easy for you because you teach chemistry. I had to work at it, and you have to work at it. I mean, there were days when I would get very frustrated and say, I'm never going to get this. And then it just clicked, or I'd sleep on it, and it would click. So, you know, especially with nomenclature, don't be too hard on yourself. The more you practice this, the easier it's going to become. And even if you have just little bits of time throughout the day, you know, if you're at work and you have a flashcard, or you can just do a few questions in between phone calls, or, you know, maybe whatever your personal life, your home life, or work life allows you to do, you know, it's helpful to just be exposed to chemistry often. Okay, now zinc oxide. I said it's not zinc 2 oxide because it's a transition metal that just has 1 charge. So the charge is written right above zinc here, so that's +2. And then oxygen is in group 6. So I'm going to do the cross and drop, and this is one. Let's slide this up a little bit. This is one where I can simplify the subscripts. So I end up with ZnO, zinc oxide. So for ionic nomenclature, practice, practice, practice. You cannot practice this too much. So homework problems, the problems online, the practice quizzes, and we have a few quizzes related to this. Make sure before you take these quizzes that you know this inside and out.